Hello there, and welcome to the second lecture of Unit 5. Today we're talking about rocks. Yay, this lecture is going to rock. Sorry, I have to say that. We are today talking about three forms of rock, three major types of rock, if you will. We'll jump right in. We'll talk about igneous rock, okay? Forms when magma or molten rock cools and hardens. So maybe you've heard the term, ignite the earth, right? Or sometimes you see it around the earth. Ignis, or igne, right? It means fire, right? So this rock forms from liquid rock, so molten rocks. We're talking about magma, as you guys know from Unit 4, solidifying and turning into a hardened rock. Sedimentary rock forms when sediment, see it there, contained in the title, deposits the form in rocks, mineral crystals, and organic matter have been broken into fragments called sediments and then get compressed or cemented together. So here we're going to see lots of photographs, but kind of layers of sediments that over time and through pressure kind of solidify to form the second type of rock called sedimentary rock. So easy to remember, sedimentary rocks made from sediments. Metamorphic rock forms when existing rock is altered by changes in temperature, by changes in pressure, or by chemical processes. All right. So later on in this unit, we're going to look at each of these three types of rocks and do little mini lectures and more discussions about each of them and kind of give you more details on how they form. But these are the three kinds of rocks. So all rocks on Earth fall into one of these three categories here. Okay. And we're going to kind of just briefly talk about some of these changes within these rocks, because all these rocks kind of change from one to the other in something called the rock cycle, which is coming up in just a moment here. Here's some photographs, just really simple ones. So with igneous rock, remember it's cooled magma. So with different types of igneous rock, you're going to see these different little crystals, these little areas here in the rock, right, that kind of look like this is granite here, obviously. You can see within granite, it's comprised of a bunch of different things kind of fused together, right? And that kind of takes place as the magma cools. So how the magma cools is pretty important. With sedimentary rock, you can actually see the little pieces of sediment here, and this looks like probably a stream bed with some definitely rocks containing iron because of that red color there. And then metamorphic rock is really going to be characterized by these bends and these layers called folates or foliation, as we're going to see later on in the unit. Okay, so that's a characteristic of that when you kind of see these waves or layers upon layers in that particular pattern. Okay, so any of the three major rocks can be changed into another of the three types. So this is almost like an idea of recycling, right? Of taking, you guys have seen the symbol on your garbage cans, right? Where the bottle or a can can be remade into another bottle or a can, right? Or we could take an aluminum can and make, a bike frame from that, right? So it can kind of be reused. So this is the same idea with the rock cycle. You can take a rock and it can be made into another kind of rock. So how does that happen? Geologic forces and processes cause rock to change from one type to another, right? So this is in the earth, so in the earth's crust. So talking about the forces of gravity in play here. We're talking about heat and pressure and all these things that happen on the Earth's surface change one rock to another. We're talking about weathering, we're talking about erosion, deposition, talking about chemical weathering, and all these changes we've been learning about to rock kind of all come into play here. So the definition of the rock cycle is the series of processes in which rock forms, changes from one form to another, is destroyed, and forms again by these geologic processes. So you may have seen the rock cycle and talked about it in other classes. It may have looked, something like this, a fairly simple diagram, right, where you have a volcano here. The volcano erupts, rock cools, and forms igneous rock, right? And then here you kind of see it breaking apart and forms sedimentary rock here, and then just another arrow over to metamorphic rock. This is sort of your old style way of thinking about it without really much detail, right? There's just there are the three rocks that kind of go around in a cycle. This one's a little better. I like this diagram here because you can see sort of the environments that each of the three rocks live in and get some basic ideas on how they form. You can see the layers here of sedimentary rock, which is nice. You can see how through a few different processes and weathering, right, the rocks kind of get smaller, then get kind of crushed up, and then form this solid layer of sedimentary rock. But then you can see again how they get close to the core, and they melt, and they become igneous, and then how they get weathered again and become sedimentary again. So this is a little bit better, but it doesn't quite have all the terms we'll need. And we'll look at one more. This rock cycle's kind of got it all, which is why we're going to talk about that for a little second here. Oh, that one word is hidden there. Sorry about that. But you can see the three different types of rock again. So we've got sedimentary up there, we've got igneous down here, metamorphic here, and you can see any kind of rock can change into another one, right? So sedimentary can be melted down in the Earth's crust and become igneous, right, after it cools, or it can be changed with changes in temperature and pressure. That's what gets cut off there, and become metamorphic, right? And each of these two rocks, metamorphic and igneous, can become sedimentary, right? If it gets weathered away, with in a stream or down a hill or in any of those other ways we've talked about weathering here. Okay, so this one's got a little bit more detail in it. So igneous comes about by melting and cooling. So it's got kind of the verbiage and the verbs with it, along with it here. Okay. So within the rock cycle, the big key takeaway is that any rock can become any other type of rock, okay? And it's been cycling like that on Earth's surface for forever, right? As long as the Earth's been around, all these rocks that you guys see and touch and walk upon have been changing throughout their lives, right? So we're just kind of recycling these same rocks over and over again in these different processes, right? So here are some of those geologic processes that form the rock from one type to another. All right. All rock has physical and chemical properties that are determined by how and where the rock is formed. Okay. The rate at which the rock weathers and the way that the rock breaks apart are determined by the chemical stability of the minerals in the rock. So as we learned in the first lecture, rocks are made of a lot of different types of minerals. Some are harder than others. Some are softer. Some react to chemicals. There's a lot of different properties within these minerals, right? So how easily a rock breaks down and turns into another type of rock is all depending on the chemical stability, right? What's inside of that rock, right? Does it have silicon, right? Does the rock, is the rock have any carbon in it? Is there iron in it? What is in the rock, right? So that kind of determines how that rock changes, how easily it weathers, how quickly it cools, all of that, right? So another idea related to that is this Bowen's reaction series. So Bowen's reaction series is the simplified pattern that illustrates the order in which minerals crystallize from cooling magma according to their chemical composition and their melting point. Okay, so the pattern of mineral formation from magma depends, again, on the chemical composition of magma, right? So let's say we've got a volcano. There's our lovely volcano. We've had an eruption, right? That magma is sitting there, right? It's cooling, and now it's forming a rock, okay? Let's call that rock A, okay? So what's A look like under a microscope? It all depends on what it's made from, right? Is it high in silicon or is it low, right? Is it cooled quickly or is it cooled slowly? Where is the rock? If it's underneath the Earth's crust, called an intrusive rock, that's going to cool at a different rate than an extrusive rock, which is out on the Earth's surface. So all these things come into play here. But the biggest thing we want to pay attention to is, well, what are these rocks made from? Okay, this gets into some chemistry a little bit, a little bit of a preview for some guys. But different elements behave differently in the Earth, right? And we're going to see that on the next slide here as we look a little bit closer at the Bowen's reaction series. All right, so this diagram looks crazy, but it's really not that difficult to understand. Okay, so just imagine, kind of look over here on the right first, and take a look at this arrow here. The arrow, as it shows, is kind of cooling, right? So a rock going from a warm temperature of 1,000 degrees Celsius, which is very, very hot, down to 600, right? So what this is showing here is that as rocks cool, they crystallize, right? So as magma cools and solidifies, minerals crystallize out of the magma in a specific order that depends on their melting points. So if the rock is a rock called olivine, which I'll show you a picture of in a second, it's going to cool relatively quickly, all right? And this rock is what we call a mafic rock. Remember that from Unit 4 at this point. So if a rock takes longer to cool, it's more felsic, or in this case, ultra felsic. Okay, so felsic rocks take longer to cool. Mafic rocks cool down relatively quickly. And all these rocks in this sort of arrow here are all different kinds of rocks. Okay, and you can see here, as you go down, as the rocks cool slower, they're more rich in sodium. If rocks cool quickly, they're more rich in calcium. So these are sort of like some of the chemicals that make up these rocks. And these chemicals are partly what determines how quickly the rock cools. So rocks that cool quickly or have more calcium, like olivine, and rocks that take a little longer to cool, like biotite mica, that sample I've shown you, I'll show you in class soon, take a little longer, and rocks that take the longest, right? So feldspar, quartz, which looks like a crystal, I'll show you that in a second too, take the longest to cool. Now they're harder, they tend to be harder, they tend to be have a little more of a rigid structure than some of these other ones, but that's because of that longer cooling process. All right, so to think about the Bowen's reaction series, again, that's just tells you how quickly rocks cool, all right, and kind of the order that they cool in, right, because some rocks will cool faster than others depending on what's in them, okay, so the chemicals that make up those rock. And again, just to quickly go back to it over here, we see the idea of mafic versus felsic rock, right? So mafic rock cools quick, felsic rock cools more slowly. All right, so here's olivine, all right, cooling relatively quickly, and here is quartz, all right, which is going to take longer to cool. All right, so if you notice that, it looks like it's got that kind of crystalline structure. It's harder, and this is just two examples. Those two rocks. I just wanted you to be able to see those two rocks. Okay, pretty short lecture. That's all you need to know. Remember, the rock cycle recycles all these different rocks. Any rock can become another type of rock, and you should know at this point what basically the three types of rocks are: igneous, cooling magma, sedimentary, cemented sediments, and then metamorphic rock, which is changed chemically in the Earth's crust from pressure or change in temperature. All right, so that's it. That's our whole lecture. Hope you have a great night, and I'll see you in class.